This is zero and negative exponents. Today, students will be able to simplify expressions with zero and negative exponents. So the first thing that we're going to look at is the idea of a zero exponent. So what I want you to do is take a look at this expression that I have written down. And we're going to kind of work through it using patterns that we know. So we're going to start in the top. I have x to the 7th times x to the 3rd. Since it's just being multiplied, I take and I know that there are 7 on the left, 3 on the right. So that's going to give me x to the 10th power because there are 10 x's being multiplied all together. Now in the bottom, I have a product of powers. I have x to the 2nd happening 5 times. And so I can multiply my two exponents to give me x to the 10th again. Now at this point, there's two things that you could think. Thing number one, you could think, oh, this is a quotient of powers. And so we subtract our exponents. All right, so let's see what happens there. That's going to give me x to the 10 minus 10, which is x to the 0 power. Now, the second train of thought that you might have is, well, wait a minute. It's the same in the top and in the bottom. For example, if I have 2 over 2, it's the same as in the top as it is in the bottom. And if I think 2 divided by itself, 2 divided by 2 is equal to 1. And so if I have x to the 10th divided by x to the 10th, it's also equal to 1. And so logical conclusion leads me to believe that, okay, if what I have in red is equal to x to the 0, and it's the same thing as what I have in blue, which is equal to 1, then I could say, in fact, that x to the 0 is equal to 1 whole. This is always going to be a true statement. Anything to the 0 power is equal to 1. The second thing that we're going to take a look at here is the idea of getting a negative exponent. So again, we're still going to use known patterns that we've already observed. And so in the top of this expression, we again have a product of powers. And so since it is a to the 2nd power happening 3 times, I can multiply those exponents. That's going to give us a to the 6th power in the top. Now in the bottom, I have a to the 3rd times a to the 4th. So I have 3 a's here. I have 4 a's there. And so altogether, I have 7 a's, or a to the 7th power. Now in this case, all we know is that this is division. And when I have a quotient of powers again, I can subtract the exponent, okay, because it's the same base. So this is a to the 6 minus 7. I have to do the top minus the bottom. And when I do that, that's going to give me a to the negative 1 power. Now, here's the thing about it. That might be quick and easy and logical, but here's what we need to understand. Let's think through what this piece means. Okay, I have a times itself 6 times. And in the bottom, I have a times itself 7 times. And so, like we've already discussed, anytime that I have the same thing in the top and the bottom, they cancel out. they make 1. So those cancel, those cancel, those cancel, those cancel, those cancel, those cancel. Okay, and so I have an A left over, but this time it's not in the top. That A is in the bottom. Everything else turned into a 1, and so I have 1 over A. Now again, if what I have in the blue box is the same as what I have right here, and what I have in the blue box turned into A to the negative 1 power, it would stand to reason that A to the negative 1 represents the same thing as 1 over A. Okay, and so the negative power indicates the remaining base is in the bottom. That's what that is telling you there. All right, so the last thing that we're going to quickly take a look at is how do we kind of rewrite or use these zero and negative exponents within all of the different things that we've been doing. So if I'm asking you to write with a positive exponent, that means there cannot be any negatives in the end. So number 1, it says 3 to the negative 4th power. This one we simply need to rewrite. There's no other base to combine it with. And so knowing that the exponent is negative, that tells me that the power, the remaining base is in the bottom. Right now, it's not written as a fraction, so I need to write it as a fraction. 3 to the 4th goes into the bottom, and I put a 1 in the top. Notice 2 different things about that. First of all, that the exponent is now positive. And also that we had to include a 1 in the top, meaning that everything had canceled out like these and made a 1, because top divided by the same bottom is equal to 1. Now number 2, we have a quotient, and when you have a quotient, you're going to subtract the exponents. So if I have negative 3 in the top, that's going to come first, minus, I have 5, so that's going to give me y to the negative 8. Again, I want to end with positive exponents. Since my exponent is negative, that's indicating that it's in the wrong place. I need to write it in the bottom of a fraction. The exponent becomes positive, and now I have a 1 in the top. Number 3 is similar to the first 2. Something to recognize is that the negative 2 exponent is only touching the x. And so technically that number 2 has an exponent of 1. So if I have 2 times x to the negative 2nd power, I could think of that as 2 times. Now again, that negative tells me to take it to the bottom, turn it positive, and then I have a 1 in the top. I'm going to multiply here, and we're going to end up with 2 over x to the 2nd power. The last one that we have here, b to the 0 times b to the negative 10. Keep in mind anything to the 0 power is 1. 1 times b to the negative 10, that doesn't change it. It's still b to the negative 10. However, again, I want to rewrite it as a positive exponent. So I'm going to put the b in the bottom. The exponent becomes positive. And there's no other numbers being multiplied by it, so I end with a 1 in the top. We're going to start combining all of these different things as we continue to practice.